Okay, yesterday we talked about just simplifying radical expressions. Today's a little bit more complicated. It's different, okay? Today's the 17th, and we are going to start looking at multiplying radical expressions. It really has foundation in what we did yesterday. So if yesterday made sense to you, this is just one step further, okay? All we're doing is we're taking one more step into the realm of radical expressions. And ideally, if you understood yesterday, this is going to be fun. Okay? It says multiply radical expressions by multiplying the radicands. That's the stuff on the inside. In each expression, as long as the index is the same. Then simplify the radical as usual. Okay? Another thing, multiply any integers on the outside of the radical separately from the radicand. So here's the deal. If you have a square root, there could be some number out here. That number is called, as it says here, is an integer. Okay? It says it's called an integer. It says this number on the inside actually has a really cool name called radicand. Okay? I think the word radicand is really a pretty neat name. My wife and I, we don't have any kids right now, but I've talked to her about possibly naming our, if we have a son someday, naming our kid Radicand. I think Radicand Novinsky is a really solid name.
It does look the last name.
If it was a girl,
Radicai.
Radicandy. Radicandy. Yeah. Radicandy. Okay. Okay.
All right.
Radicandy. Okay. So here's the deal. There's some number on the outside, and it's very yes. I printed it. Excellent. Thank you. Yeah, I know. Yeah. Guess what? I use the @ symbol too sometimes. So here's the deal. There's some number on the outside. There's some number on the inside. What does it say you do with those?
Multiply. Simplify.
Sam, turn around. Put your chair down. Make sure you're paying attention. Okay. There's two numbers. There's a number on the outside. There's a number on the inside. It says you multiply them and keep them where they're at. So if it's a number on the outside, keep it on the outside. If it's a number on the inside, keep it in the inside. Okay? But you multiply them together. So here's the deal. Number on the inside, number on the inside. What do? I multiply those together. I now have the square root of 6. Is that a piece of cake or what?
Wait, hold on. Say that one more time. What?
Square root of 3 times the square root of 2. 3 times 2 is 6, so it's the square root of 6. Can I simplify the square root of 6 any?
Yeah. Oh, I think it's easy to ask, but no, we can't.
No, you can't. Okay? Look at this. Now we have a number on the outside, number on the outside. We multiply those together, so 3 times 2 is 6. And then number on the inside, 6 times 3 gives you 18. Okay? It's all right. Hey, it's all right. Now, are we done?
No.
Okay. At this point, hold the phone, guys. 18. We need to divide this. So we can say this is 6 and 3. 6 is 3 and 2. Are there any pairs?
Threes.
There's a pair of 3s. So basically, on the outside, we already had a 6. And now we have a 3 that we're multiplying together. What's left over on the inside? A 2. So we have 6 times 3 is 18. Square root of 2. That's our final answer. Let me go over that one more time, just so you can see it. We multiply what's on the outside, the 3 times the 2, that gives us the 6 on the outside. We multiply the 6 times the 3 on the inside, so that gives us the 18 on the inside. At that point, we're going to try simplifying the new radicand, which gives us 3 times the square root of 2. Multiply the 6 times just the 3, because those are the numbers on the outside, to give us 18 square root of 2. Okay? Questions on the first two?
No, sir.
Next one, outside. We should have 3 times 5 is 15. 6 would be 6 times 2 is 12. Brett, how do I break up 12?
6 and 2.
6 and 2. And what else?
2 and 3 and 6.
2 and 3. Okay. Any pairs?
2.
2 and 2 is a pair. So I'd have 15 times 2 square root of 3. What's 15 times 2? 30 square root of 3. Great job. Okay. Next one is a little different. I hope you're paying attention. It's a little bit different. Square root of 5 squared means that we have the square root of 5 times the square root of 5. Okay? If I was to multiply the square root of 5 and the square root of 5 together, two inside things that have the square root of 25. What is the square root of 25?
5.
5. So there's kind of a shortcut here.
Wait, you just say so we do 5 times 5?
Yes, because they're both on the inside, so you just pull those together. Johnny? Help me. Okay? There's a shortcut though. If you ever square a square root, they undo each other.
Yeah.
Square and a square root undoes each other. So if I said, hey, what's the square root of 6 squared? What's the answer?
36.
It's 6. Okay? If I said, what's the square root of 19 squared?
It's 19.
It's 19. If I said, what's the square root of 72,000 squared?
72,000.
72,000.
But we have squared.
So this is the shortcut for it. You do not need to write all this stuff out. If it just says the square root of some number squared, it's just that same number back. Okay? Otherwise, you can expand it. You can expand it to give you square root of 5 times square root of 5, which is what squared means. You're multiplying by itself. Put those two together. Okay. So how does squaring work when there's a number on the outside and a number on the inside?
You times them both.
You're multiplying both. So 7 times 7 is
49.
49. Square root of 3 times square root of 3 is
3.
3.
Somebody says 9.
It is the square root of 9, which is 3. But all we have to do is say, hey, the square root of 3 squared is 3. If you really want to write it out as the square root of 9 and then realize that's 3, you can do it that way if you really want. What's 49 times 3?
147.
147.
147 squared.
Why do we use
And to
square
check
root
your
of
answer, you can put it straight.
Because we're squaring this number. If you get 49, we square this number. If you square on the inside, it would be a square root of 9. If you just realize that the whole thing was squared, you just have squared. Either way will work. Whichever way works best for you. Number 6. We square the 2 on the outside, that gives us a 4. We square the square root of 2, which gives us 2. So our answer is 8. I'm not trying to make this look really easy. I'm just trying to show you what we have here. Okay? You just square each of those separate components and realize what we have. Janelle, do you have a question? Yes. No, you may not go to the restroom.
I was going to ask that.
Okay? I was just answering it.
Okay. But, hey, how do you know that?
I have ears on my head, and you were proclaiming to the entire classroom, hey, I really have to go to the bathroom. And then Brett talked to you about, like, hey, it's really fun that you mentioned that to everybody. And then Tucker said he really enjoyed hearing the conversation.
Okay.
Did I hear everything?
He's on the internet, too.
Sherry, what's your question?
I forgot.
Square root of 5 times the square root of 20. This would look like this. It'd be the square root of 5 times 20 is 100. What's the square root of 100?
How'd you do that? You don't put like a square sign over it?
5 times 20 is 100. Square root of 100 is 10. That's one of those you had to memorize. It's a perfect square. How about that? Number 8. 10 times 5 is 50. So we're dealing with the square root of 50. Square root of 50 breaks down into
5 and 10. 10 and 5.
That's right, 2 and 25.
Oh,
Which is 5 and 5.
why don't we do it the other way? Oh, yeah.
I really like to emphasize the idea that you'll use the perfect squares You can break these into perfect squares.
I have to use the person.
No, you may not use the restroom.
I don't have to use that.
Yes, you do.
Okay, I do, but I'm gonna ask. Can I just ask my question?
You just asked me a
Can
question.
I just ask a question?
I'm going to talk to Tyler first. Tyler, what's your question? Because he raised his hand.
Should we simplify 25? Get 2 back, right?
That's correct.
Would you times 5 times 5 times the square root of 2?
The idea is that what we have on the inside of the square root is technically 2 times 5 times 5. That's the same thing as 50. These two are the same. What we look for is in a square root is are there any pairs? If there is a section of pairs, you can pull it out. You can pull one of them out. Okay, that's why it's 5 to the square root of 2. Andrew Palmer. Stop it. Janelle. Okay.
Oh, I remember now.
Sarah, do you have a question?
Yes.
No, you may not use the restroom.
Stop saying that. Okay, like we have like a number like 224. How do you know automatically we can break it down into?
Is it a perfect square that we memorized?
18.
Is that really a perfect square?
Yes.
No. Oh yeah, it's 8.
8.
It's 8.
Okay, well like what's like 352?
102. Is it a perfect square that we talked about?
No.
No, it's not. So, when in doubt, we know it's divisible by 2 and 76. It'd be like 4 and 19. That's 2 and 2. Okay? If you don't recognize it, it's fine. Like you didn't recognize this was, 25 and 2, which is fine. It'll still give you the same answer. I'm just going for the quickest way. That's what a student over here said. You were louder with yours, but I went with the one that I was actually said first. So you said 5 times 10. And another student said 2 and 25 first. That's why I wrote that one down. I wasn't doing it because yours was wrong or anything else. I just wrote down the one that I heard first. Okay. Either way would work. Square root of 7 times the square root of 7. What do we get? 7. How do you know that? Two different ways. You could say that that's the same thing as saying the square root of 7 squared, which we know is 7. Or you could say, hey, by the way, that's the square root of 49, which is also 7. Okay? Either way, there's different ways of doing these problems, but in the end, if there's a long way or a short way or any way that we've talked about, just realize you're still going to get the same answer back. Okay? Do you want to see an even harder way to do this?
No. You're gonna confuse us.
Yes. Nuh-uh.
I'm close my eyes.
You can still hear it.
Okay. This is 3 and 8. This is 16 and 2, which is 8 and 2. When we do this, one way we can do this is we can break down each one of them separately and keep track of what's going on in here. We would have a pair of 8s that I could pull out, which is 8. I have a pair of 2s which I could pull out, which is 2. And what's left over is 3. I could have an answer, square root of 16, or 16 times the square root of 3. I could do that because each of these is broken down sort of separately. Or what you can do is you can actually multiply them together first. Okay? So what's 24 times 32? What is that number? Okay, 768. So we can start off with 768. What would be two numbers that make 768? Well, two numbers I would pick would be like 24 and 32. How did I pick those? Well, I just multiply them together. I know that they're multiples of it. Okay? So the idea is that if you do multiply this together, you get 768. Then realize that probably just break it down into exactly what you just had. I just sort of saved a step by breaking down the initial numbers first. Tyler.
You broke down the 8, was it 24? You said it at the same time.
Yep. If you kept breaking this into 2, 2s and 2s, 2, 2s and 2s, it'll be fine. It'll be the same thing. Yep. Yep. I just stop when I see pairs. Why don't you guys try number 11? Try number 12 as well. Some of you have already tried them. I want to give everyone a chance to do this on their own. I did not use a calculator for that. My math might be a little bit off. I apologize if it is. How many did anybody get 288 for the first one? Right. Did anybody get 270 times the square root of 2 for the second one?
I got 381. 381.8.
381.8 will be absolutely wrong. We are doing exact answers. You're not getting decimals. This is the point of not this. We don't get decimals on purpose. Yes, sir.
Why would you have two 12s if you ain't got one?
This 12 is from the outside. This 12 is from inside. That's why there's two 12s. Because there already was a one on the outside from the 4 times 3 is 12. And there's going to be a second 12 because there's a pair of them that goes like that. Brett?
Number 12, I got 270 times square root of 8.
This 9
I don't know.
can be broken down to 3 and 3.
I did 18 and 25. 450.
Okay, so you said 18 times the square root of 450, which is what now?
18 and 25. And then 9 and 2. And I broke 9.
So you have a pair of 3s, so you have 18 times 3, a pair of 5, which is times 5, and then what you probably did is you used that 2 and the 9 again.
Oh, yeah.
The 9 gets broken
Yeah,
down
I
further.
did that. Yeah.
So you'd have the same thing.
Alright.
Yes, ma'am.
Okay, for 11, I did 40. I broke like 48. I did 6 times 8.
Well, let me write this down. What did you have?
I 48 and 12.
Okay, sorry, you had 12 times the square root of 576, 48 and 12.
Yeah. And I broke down 8 to 6 times 8.
6 times 8, yep.
And then 12, I did 6 and 2.
6 and 2. Are these any of these numbers prime?
I don't know, but I just saw 6 there.
Okay, so you saw 6s, so that's a pair of 6s. Got it?
But I didn't know what to do.
So you can pull that 6 out, that's fine. But now what about this 8?
Do I have to?
You gotta still break it down because it's not prime yet. So that'd be like 4 and 2 and 2 and 2. So that'll give you a pair of 2s like this.
So 12 times 6 times 2?
And another pair of 2s right there. Yep. And that would give you the 288, I think. Is that alright? So just, honestly, I have a bad habit of stopping when I get a pair. But it's only when it's a pair, then everything else is prime. Okay. Cool. Other questions? I want to give you some advice. You can take it for what it's worth. It is advice for you. I did say we are having a test coming up soon, which is good.